All right, to start off, we have a definition from dictionary.com. Asymptote. A straight line approached by a curve as one of the variables of the curve approaches infinity. So in other words, we have a line, and as we call this the x-axis, say, our curve as x gets infinitely large, it's getting closer and closer and closer to some line. And there's some advanced texts that say that an asymptote doesn't even have to be a line. It could be a curve itself. But we're not going to deal with that. We're going to deal with straight line asymptotes. And we're going to start today looking at rational functions. The simplest rational function is 1 over x. It's called a rectangular hyperbola, and its graph is pictured here. It is symmetric across the line y equals x, the line y equals negative x. If we folded this graph on either of those dotted lines, we have a mirror image. It goes through the point 1, 1 and negative 1, negative 1. And it is asymptotic. It approaches both a horizontal and vertical asymptote. Notice that we can't put 0 in the denominator. We're undefined there. Hence the vertical asymptote. This graph exists in only the first and third quadrant. We have our symmetry. And now let's look at what happens as x approaches infinity, as x gets infinitely large. As we go that way. Our graph, our f of x value, is getting closer and closer and closer to 0. As x approaches negative infinity, as we go really far to the left here, what is our output doing? Our output is getting closer and closer and closer to 0 again. So we have an asymptote at y equals 0. We call this statement right here the end behavior. Now, also as we approach this undefined value, what's happening? As x approaches the undefined value of 0, as x gets closer and closer to 0, our graph, our output, is getting infinitely tall. It's approaching infinity. As x approaches our undefined value from the left, our graph is approaching negative infinity. And because our graph is shooting up along the y-axis and shooting down along the y-axis, both at x equals 0, we have a vertical asymptote on the y-axis, otherwise known as x equals 0. Before I get going too far, I need to make sure I've got my calculator open, which I don't. So let's proceed a little bit further now. So horizontal, vertical asymptotes, we're going to deal with these rational functions that are just shifted versions of this. So from now on, we can say, holy shift, look at the asymptote on that mother function. We call this thing the parent function, because all other graphs start from this. And they're all going to have asymptotes, and they're all going to be shifted versions of that. And the type of rational function we're going to focus our energies on is when we have a linear equation, ax plus b, divided by another linear equation, where c doesn't equal 0. And let's look at why that would be. Why don't we want c to be 0? Because then this goes away, and we end up with a over d times x plus b over d. And that's just a linear function. There is no asymptote. It's not rational anymore. We want x to be in the denominator. Without x in the denominator, it's not a rational function. To determine the equation of the horizontal asymptote, we're going to consider what happens to the graph, the behavior of the function, as absolute value x goes to infinity. So what happens out at the ends? So we have this function. Find the asymptotes, find the axes intercepts, and use technology to help sketch this function. Now there's a real easy way to do the asymptotes. If we think about the parent function, 1 over x, we know where the asymptotes are. They're the x and y axes. We can apply certain shifting techniques that we have in the past. We've seen these types of letters, H and K, that shift us horizontally and vertically. So this 2, the fact that it's minus 2, means that there's a horizontal shift of right 2 units. And this plus 4 tells me I'm moving up 4. So this hyperbola that was like that is now having to shift up 4 and to the right 2. So I'm going to start to cut in my graph here. Here's a coordinate plane. I need to draw my asymptotes. I'm going to move my horizontal one up 4 units. There's my horizontal asymptote. My vertical asymptote moves right 2 units. Look at that. So now my horizontal asymptote is the equation y equals 4. My vertical asymptote is the equation x equals 2. So I've got part A knocked out. Find the axes intercepts. Okay. Remember we find that by plugging in to find the y-intercept. We let x equal 0. So 6 over 0 minus 2 plus 4. So our y-intercept is at 1. X-intercept. Remember, to find our x-intercept algebraically, we let y equal 0. So 0 equals 6 over x minus 2 plus 4. I'll subtract 4 from both sides. 6 over x minus 2 equals negative 4. We can multiply both sides by x minus 2. Distributing, we have negative 4x plus 8 equals 6. So x equals negative 4x equals negative 2. X is 1/2 apparently. So right there. So far I've got 2 intercepts and 2 points. To get a better graph and really to do all of this stuff in the pink here, we could have gone to our calculator. I'm going to throw in a graph page, and we have 6 divided by x minus 2, and I forgot my parentheses. Notice there it is shifted horizontally. I've got to throw on the plus 4. There we are. And I can grab right here to adjust things a little bit. And I'll show you that we do have our asymptotes in the right spots. At 2, there's our vertical asymptote, and at 4, we have a horizontal asymptote. So, and looking at this, y-intercept of 1, x-intercept of 1/2, that looks about right here. And now we can find other points on this graph simply by adding a table. I'm going to go Menu, Table, Split Screen Table. And here's a whole bunch of points that we can plot now. X equals 0, y equals 1. There is the y-intercept. Remember, to find the x-intercept, I can go Menu, Analyze Graph, 0. Set my lower bound, upper bound. There's my 0. So these things should be pretty easy to graph with the help of technology, and really they shouldn't be very difficult without technology either. Because what we really could do, we could simply make an XY table and plug in different values of X and find values of Y. However, if we have our calculator, you better use it. It'd be silly not to. So here's another problem. This one's written a little differently. It's not written in that form 1 over x minus h plus k. It's different here. So we're going to take a slightly different approach to finding our our horizontal asymptote. Our vertical asymptote we can still find by thinking about what would make the denominator 0. X equals 3 is our vertical asymptote. And don't abbreviate asymptote as ASS, please. That would be really bad. Now for the horizontal asymptote, we're going to go right to our calculator. 2x minus 9. I'm going to add a fresh page. Parentheses 2x minus 9 divided by 3 minus x. And once again, I forgot my parentheses. There we go. So to find our asymptote, and you might be able to look at this graph and get a pretty good guess of what it is. But what we're going to do is we're going to go right to the table. We want to know what's happening as x gets really, 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 really big. So what I'm going to do is I'm just going to roll down here. And as x is getting really big, this graph happens to be getting really close to -2. So our horizontal asymptote is y equals -2. Domain and range. Domain, set of all x's such that x does not equal 3. Range, the set of all y's such that, is it all real numbers? No, because it can't be y equals -2. It never hits that value. Axes intercepts. All right. So let me roll back up here. Let's see if I can change my... Let's change my start value to 0 again. Get back up to the top. So when x is 0, y is -3. Well, that's my y-intercept. Cool. (0,3) or 0, -3? I don't remember. -3. All right. Now we also need x-intercept. So Again, using calculator to help here. Make sure you click on your graph. Press tab to get over there. Menu, analyze graph, 0, lower upper bound. There's my 0, 4.5 comma 0. Discuss the behavior of the function as it approaches its asymptotes. So as x approaches infinity, y approaches negative 2. As x approaches negative infinity, y also approaches negative 2. And then we talk about what happens as x approaches its vertical asymptote. As x approaches 3, y is going up. There's our asymptote. As we approach 3 from the positive side, we can show that with a little plus, y is going upwards. As x gets closer to 3 from the negative side, y is approaching negative infinity. That is, y is going down. And now we want to sketch the graph. And we have the calculator, we have the information that we've written down. This should be easy peasy lemon squeezy from here. So 0, negative 3, 4.50. We have a horizontal asymptote at negative 2 that our graph is not allowed to cross. Vertical asymptote at 3 that our graph is not going to be crossing. And we can jump to our table again. 2, negative 5. Get a few more points on here. 4, 1. And there's our graph. We should be able to do most of this without the calculator. However, the calculator is a very powerful tool for graphing this. These asymptotes, at least the vertical one, you better be able to get with no calculator.